Welcome to my video on integer exponents. In this video we are going to look at exponents that are positive, 0, and negative and figure out how can we evaluate them. Now as we see in front of us, I have a list of exponents on the same base. The base is 3 and the exponent is 4, or 3, or 2, or 1. Then we have 0, -1, and -2 as our exponents. In order to start figuring out what these negative exponents are going to be, we need to first discover a pattern. So that's why we're starting all the way over here with 3 to the 4th power, which is 81. And if we're not sure about that, remember 3 to the 4th power means that our base, 3, is being multiplied against itself 4 times. 3 times 3 times 3 times 3 is 81. Then we have 3 to the 3rd power, which works the same way, except I'm not going to have as many 3's. I'm going to have just 3 3's. 3 times 3 times 3 gets me 27. And this is how exponents work. But when I start getting into the 1's, 0's, -1's, -2's, and so forth of our powers, that isn't as intuitive sometimes. So let's take a look at our original examples that we have here and see if we can discover what the difference is. So I have 3 to the 4th power, which is 81, or 3 times 3 times 3 times 3. Alright? That all gives me 81. But if I get rid of one of the 3's, now I have 3 to the 3rd power, which is 27. And another way we can think of this is, all I did was take 81 and I divided by 1 3. To go from 3 to the 4th power down to 3 to the 3rd power, I have to divide by 3. I got to get rid of one of those 3's that I multiplied by. And the pattern continues. If I'm going to go from 3 to the 3rd power to 3 squared, I once again have to divide by 3. And when we get from 3 squared down to 3 to the 1st power, and now is where we're going to start filling in what the pieces we don't have, 3 to the 1st power is really 3 to the 2nd power divided by 3. And what is 9 divided by 3? Well, it's 3. So we've filled in ones that we probably could have figured out on our own. 3 to the 1st power is 3, 3 squared is 9, 3 to the 3rd is 27, and 3 to the 4th is 81. But now we're going to have 0, -1, and -2. Many people think that the 0 power means that our answer will be 0. This is absolutely incorrect. It is not 0. Look at the pattern that we noticed here. Every time my exponent decreased by 1, I divided by the base. So to go from 3 to the 4th to 3 to the 3rd, I divided by 3. 3 to the 3rd, 3 to the 2nd, I divided by 3. Same here, I divided by 3. So if I'm going to get to 3 to the 0 power, I'm going to need to divide by 3 again. And what is 3 divided by 3? It's 1. And this is true for any base. It doesn't have to be 3. Any base raised to the 0 power is 1. And now we can figure out our negative exponents as well, because this pattern still continues. So I have 1 divided by 3, and this is 1/3. And once more, going all the way to the end, divide by 3 once more, and this is 1/9. So there we have it. When we have positive exponents, our numbers get bigger. When we have negative exponents, our numbers are fractions. And we'll learn a little bit more about this in just a moment, but this is a nice way to start learning about integer exponents. Alright, let's get rid of this and take a little bit closer look at some other examples. For this example, we have 2 raised to the negative 3 power. Now we could make a table like we just saw in order to solve this, but there's got to be a faster way. And thankfully there is. A negative exponent means that we really have a fraction, and I could rewrite this as 1 over 2 to the 3rd power. That negative exponent tells us that whatever it is attached to is in the denominator. So 2 to the negative 3rd is really 1 over 2 to the 3rd power. And when I evaluate that, 2 times 2 times 2, well, that's 8. So this is the same thing as 1/8. Let's take a look at a different one. If I had, let's say, 4 to the negative 5th power, well, that's going to be the same as 1 over 4 to the 5th. All I had to do was take whatever the negative exponent is attached to, that 4, and put it in the denominator with a positive exponent. And 4 to the 5th is, well, let's see if I can figure this one out. 4 times 4 is 16. I'm going to have another 4 times 4, which is 16. And then that's going to be multiplied by 4. So 16 times 16 times 4. 16 times 16 is 256. So we are going to have 256 times 4, which is 1024. So 1 over 4 to the 5th is the same thing as 1 over 1024. Big number. Power of exponents. They get big fast. Or small fast. Because actually, while 1024 is a big number, 1 over 1024 is a small number. All right, I'm going to put a couple examples up here. I want you to take a shot at them. See what you can do. Okay, so let's clear out what we have. Why don't you see if you can figure out 5 to the negative 3, 2 to the negative 5th, and 1 to the negative 7th. What would those look like? Feel free to pause the video and give it a try. Alright, hopefully for 5 to the negative 3rd, you started off by rewriting it as 1 over 5 cubed. And then this becomes 1 over 125. 2 to the 5th, 2 to the negative 5th, hopefully you wrote as 1 over 2 to the 5th. And when you evaluated that exponent, 2 to the 5th, you got 32. So we have 1 over 32. And then lastly, we have 1 to the negative 7th, which we could rewrite as 1 over 1 to the 7th, which is just 1 over 1, or 1. So anytime 1 is raised to a power, could be negative, could be positive, could be 0, it's going to stay itself. It doesn't change. Alright, so there's our first little introduction to integer exponents. We'll do more with these, but now let's try evaluating them because, of course, this is algebra. We're going to see these with variables. So let's take a look at some examples with variables. Alright, here I have 8a to the negative 2. And I want to write this with a positive exponent. I don't want it to be to the negative anymore. So you got to ask yourself, what would I do here? How can I make this positive? Well, we might be thinking, oh, we'll do exactly like we did before. We'll take what the exponent is attached to, and we'll put it in the denominator. So you might be thinking, oh, this is going to become 1 over 8a squared. And I would say to you, you are very, very close. But this is not correct. Because what is the exponent attached to? If I had parentheses around the 8a like you see here, this would lead us to here. That will be good. But I don't have parentheses. The parentheses are not there, and all I have, oops, let's just get rid of it like this. all I have is the negative 2 on the a. So really, this would become 8 over a squared. You only move what is in, or what is connected to the exponent. 8 is not connected to the exponent. 8 is connected to a, but the exponent is connected to a. So the exponent and its base go to the bottom. Then, after I have this, what I could do is say, hey, evaluate for a equals 2. Well, if a is 2, that means I can rewrite it as 8 over 2 squared, which is 8 over 4, which becomes 2. So if we're evaluating, we first want to make our exponent positive by moving it into the denominator, then substitute whatever its value is into its place, and then evaluate and divide. Alright, now let's take a look at the other example I have over here. This one looks a little bit bigger because I have two variables. I've got x and y, and I've got a 7. So let's move this over to the middle. And what do we got here? 7x squared y to the negative third. Well, hopefully after that last example, you have an idea of how we're going to get this exponent to be positive. We want to move whatever is attached to this exponent to the denominator. And hopefully we say y is the only thing the exponent is attached to. So this is going to turn into 7x squared over y cubed. Now I have all my positive exponents. That's a good thing. And if x equals 5 and y equals 4, well, we can then say we have 7 times 5 squared all over 4 cubed equals 7 times 25 all over 64. And that's going to give us 175 all over 64, and I don't think there's anything we can divide those by. Not positive on that, but I'm fairly certain that we have to leave it like that. Alright, we've talked about negative exponents and how we figure out their value. We've talked about how, when the exponent is negative, we move it into the denominator. And really, and also we talked about how we evaluate it once we know what the what the variable's value is. So, I'm going to put up two examples. Feel free to pause the video, try them on your own, and then that's going to be it for today's video. Alright, so let's get these two examples up. Alright, here are our last two examples. We've got 2r to the 0, m to the negative 3 for our first one. And over here we have r to the negative 3 over 7. Feel free to pause the video, try these on your own, and give them a chance. Alright, hopefully you tried them. For the first one, I want to first make sure my exponents are positive, so that means I'm going to have to take whatever this negative 3 is attached to and move it to the denominator. Well, it is attached to m, so I'm going to first rewrite this as 2r to the 0 over m cubed. Now I'm told what r and m are. r is 3, m is 2. So I can plug those values in to have 2 times 3 to the 0 power all over 2 to the third power. Now, what is 3 to the 0 power? We talked about that at the very beginning of this lesson. Anything to the 0 power is 1. So I really have 2 times 1 all over 2 to the third power, which is 8. So I have 2 over 8, which is 1/4. For our final example over here, I have r to the negative 3 over 7. If I want my exponents to be positive, I need to move r to the negative 3 down to the denominator. That's going to be 1 over 7r cubed. The 7 stays down there. It does not get moved up to the top. And I'm going to take the r value from over here again. So what I have is 1 over 7 times 3 to the third, which is 1 over 7 times 27. And 7 times 27 is 189. So I get 1 over 189. And there we have it. Hopefully these are the answers you got, and you now have a beginning understanding of integer exponents. Good luck.